Some of you guys have seen this one, some of you didn't get to it that day. And so this is the one where we hold the magnesium in the thing. So Geralda, you get another day, babe. So if you want to come watch, you can. Okay. Oh, all right. So let's talk about elements. Ready? Let's talk about elements. This is magnesium, right? This is in the presence of fire.
That's like a cigarette.
What's the only thing that magnesium has available in this room to react with?
Air.
Air. What are the main components of air? Oxygen is the smaller part. What's the bigger part? Nitrogen's the bigger part. But magnesium won't react with nitrogen, but it will react with the oxygen in the presence of heat. So sitting out here like this, eventually after a year or so, it's going to get gross looking. So speed it up with fire. So Noah's going to put it in the flame. Don't look directly at it. So look over to the side. Look over to the side about 6 inches and you're fine. When you blink, you'll keep seeing it. Now blink a whole bunch of times. You see it?
I don't see it.
Oh my god, I see it.
Wait.
I do. It's like.
We want to do it again because it's fun? It does remind me of welding. Has anybody welded before?
No.
Is anybody going to take welding at HCTC next year?
No.
No? Cool class. You can actually get your welding certification and you can graduate and have your welding certificate. Okay, one more time. Ready? So magnesium plus oxygen in the air. So what is this white stuff then? What did we make? There's no nitrogen. There was only magnesium and oxygen. Ooh, that's weird. Okay, oh, hold it out. It's more fun. So when you put it down on the table and you crunch it up with the tongs, because it's hot, I don't want to touch it. It's a powder now. It's not a metal anymore.
Cocaine.
So we made a silver metal turn into a white powder. So it's definitely not cocaine. Okay. I'm not cool enough for that. And that's dangerous. Oh God.
Really.
One time died.
I thought you said you one time.
No, I'm obviously still here, so I did not try it one time and die. Anyway, so magnesium and oxygen. What's the only thing that can happen?
Explosion.
It didn't explode. They're going to say it again. They're going to come together. So if magnesium and oxide come together, what are we going to call it? Synthesis. But what are we going to call the new compound? What is this?
Powder.
Magnesium oxide. So we made magnesium oxide powder come from magnesium metal and air. Pretty weird. Okay, so that was a synthesis. 2 single elements came together. All right, shut that off. Let's go. This one's boring, but I'll show you real fast. So this is just salt water right here. Woo.
Okay,
Got a little excited there, dude. Calm down. I can do this all day. I want to do like a little show for elementary kids and invite them over. That'd be cute. All right. All right. So here is some silver nitrate. Ready?
Color change. Transference.
So it's actually turning into
Ice.
a powder. It kind of does look
She said ice.
I would have thought it. But I think it looks cool, like when the drops go down and it swirls around like that. I don't know.
Oh.
And it gets totally cloudy. If I left this overnight, all the white powder would sink to the bottom.
We'll leave it over.
And all the clear would
Is that what they put in those like magic wand, the little I Spy sticks?
No, I don't think so. I don't think so. But silver nitrate's pretty weird, but it actually breaks down in light, so I can't keep it in that glass. But I'll leave it. We'll see what it looks like here to touch. And so I'm gonna ask that you be really careful and so this is hydrochloric acid. Hydrochloric acid is very corrosive. I wrote scary on the label so kids would know that it's scary. So I'm going to put some hydrochloric down in the bottom of here.
She does.
So one thing you need to know about acids is that I can't store acid in a metal cabinet because acid and metal don't get along like the soda can. And so I have to store it in glass and I can't put it in a metal cabinet because one year I tried and it rusted all the hinges shut. And they had to like ruin the cabinet to get everything out of the cabinet. So what I'm going to do is I'm going to take some zinc metal. Remember, acid doesn't like metal. And we're going to put it in the acid and we're going to see. Okay, everybody take one step back so I feel like I'm being safe. All right?
I don't know, what is it? Why y'all backing up?
So that zinc is making that acid, mad, and what's it producing?
Heat.
Look,
Bubbles.
gas. So there's
Gas.
gas coming out of there. I'm going to trap that gas in this test tube right here.
Ooh, it smells.
Anybody got a pair of goggles they want to put on? And do this part for me?
Okay, yeah, Noah.
No, let somebody else do it now.
No, me.
Okay, so now, look what I just did. It was full of water, but I just forced all the water out. So what I need you to do is light a match. So inside here, there's no more water. There's just this unknown gas that I created. And so hold the match, ready?
Hell no, yo.
Ah, that was lame. Let's see if I can do it again.
I'm gonna do another one.
Okay.
Yeah.
So notice that the air, the gas is lighter than the water, so it's forcing the water out of the tube.
Come on, miss.
You're gonna burn her fingers.
I'm gonna burn the crap out of my
Did I get the water out yet?
fingers.
Don't light it till she says light it.
Yeah, okay. Yeah.
Okay, I think it's empty. All right. Okay, go ahead. Okay, hold on. Okay, now hold it just about an inch under. There we go. So what that just proved is whatever this gas is that filled up in this tube, that gas is flammable. That's hydrogen gas. Have you ever heard of a hydrogen bomb? It's worse. It's the worst nuclear weapon we could ever have. And we've tested one once, and we said we will never do that to another country. And so this gas is so flammable, so we don't make hydrogen bombs anymore. So that was a positive hydrogen test. That's what we call that.
Oh!
All right. I don't think do I have time for any more?
We have time for one more.
That time your answer would be no. Okay, but we really can with an experiment. So this is just water with a little bit of salt in it. I needed it to be a conductor, and water's not a very good conductor, so I doctored it up with some salt. This is that universal indicator that I used in the rainbow swirl that changes all those rainbowy colors. So I'm going to put some drops in there so it's a little bit greenish, okay, which means the water's neutral. Then what I'm going to do is I'm going to use this battery right here, and I'm going to conduct an electric current, and I'm going to put these into each side of the water. At first, nothing's going on, nothing's going on, nothing's going on. But since there's salt in that water, we're trying to see if there's a current going through the water. Do you start to see bubbles or a color change?
Color change.
On my left hand right here,
Oh, now it's purple.
it's starting to turn purple. And can you see the baby bubbles produced?
Yeah.
Those baby bubbles are a gas. I am taking water and splitting it into hydrogen gas and oxygen gas. So if I did this long enough, I could get all the water to go away and turn into gases. Now, the color change on my right hand is harder to see. What color is it turning barely?
White.
Kind of like a light yellowish. But which one's more? Who do I have more of?
Purple.
I have more purple. That means that this side, since there's more of it, is the hydrogen 2 part of water. And this side over here is the oxygen part. So this side is producing oxygen gas, and this side is producing twice as much hydrogen gas to make H2O. So we are splitting water into hydrogen gas and oxygen gas. This would take forever, like overnight, for me to leave these in here, for it to evaporate and bubble off and go away. So it's not fast, but the color change I thought was pretty cool, that it indicates that, hey, you're making hydrogen on the purple side and you're making oxygen on the yellow side. All right, that's all I got for you. That's all I got for you.